Hello, December 22nd, 2024, and we've come to problem 2 of section 2 in chapter 4. Actually, doing this for some instances is part of studying the section. So I actually did some of the work needed here already while studying. That is until I realized that it was a problem, then I stopped. The idea to solve it is to distinguish at least 4 cases. Lambda may be even or odd, and then -1 to lambda L can be equivalent to 1 or 2 and 3 modulo 4. Well, that's at least 4 cases. I don't know if we need to distinguish further cases. And then it's just getting started. So we need the original formulas for BL, which I have taken here in this case. And then let's assume on this page that lambda is even. And then it's just starting to work on the problem. It really takes a lot of space. So this L we have here in case lambda is even, and we have the uppercase. That was this part. Now zeta of 2 lambda. I didn't write that up. I should have. Checking 2 lambda minus 1 minus lambda divided by gamma lambda. All right. There we go. That was the first factor. And then the rest we can copy. And then this, let's take e to pi I lambda halves, and then e to pi I divided by 4, that's 1 plus I times square root 2, or divided by square root 2. This we should be able to reduce as well, like -1 to lambda halves. And we have, that's an integer. We'll just check what comes out. Let's see if something cancels as it is. That would be nice. Pi to lambda minus 1/2. Pi lambda, that's pi to 2 lambda, which we have here. So we get a square root of pi. I didn't see that anywhere. We'll just write it. And n, that's a little weird. I thought that should cancel. On the other hand, what is n here? That's the order of the no, the conductor of this character. And in case, which case are we working on really? When it's even equal to 2 or 3 modulo 1, then it's just L. And if it's equivalent to 1, then it's 4L. So that means here it's L to, I'll just check that so I don't make a mistake. In this case, N equals 4L. So L here cancels, and then we have 2 to 2L minus 1. And 1 minus 2 to minus 2L. And we'll see later what we'll do to this. And then square root 2 let's just put it here for the time being. And then we have the gamma functions. I think I've written an F here instead of gamma. The sum of these two is unity, and that means it gives pi divided by sinus pi lambda. Pi lambda plus 1/2, so it's pi lambda plus pi halves. I think we'd rather have leave it for the time being. And what more do we have? We have when there is 1/2 between them, the product with 1/2 between them. Maybe we should extend it by 1 minus 1/2. I think that's what we do. And the same down here. Or am I overcomplicating here? If we take it 1/2 plus everything should come out to the same, but a genius would probably know what to do here. So the smaller one should be half an integer. oh, look at this. They add up as well to a unity. So we should actually do the same here. So that's an overcomplication. So these add up to unity as well. That's not the gamma function. That's the L function. So back to what I said before. When using this formula, we would like the smaller one to be half an integer. And that's not what we have here. Or on the other hand, this is the smaller one. I forget right now what lambda is. I'm so entrenched in this. What is lambda? Oh, yeah. So that's a positive number. Or is it? Well, never mind. Let's assume that. So we work this way. And we take this one first. So that's pi to 1/2. To 1 minus lambda. Gamma of twice the larger one. Or actually that might be whatever. We'll just check where we should end. All the gamma functions should vanish, cancel. So this is the smaller one, and that was 1 minus lambda. So that's what we substitute. Oh, yeah. S in the formula is 1 minus lambda. So 2 to 1 minus lambda, gamma of 1 minus lambda. Right, and then we have the product, and that is blue, of gamma 1/2 lambda and gamma 1 minus lambda halves. So that's pi divided by sine pi lambda halves. square root pi, we'll just put our cancel pen green. So square root pi, and pi cancel. Lovely. And then we have 2 to 1 minus lambda. That gives 2 to lambda. That was wrong. This is not cancelling like it should. There's something wrong here. We'll just let that be a question mark for the time being. And then we must use the transformation formulas here. This is actually pi lambda. If lambda is even, then it's a multiplum of 2 pi. So we just get sine of pi halves. That's unity. And here sine pi times an integer. Oh, that gives naught. That's terrible. So shit vanishes here. Not good. And what happened to my zeta function here? 1 minus 2 lambda. Well. Like I to lambda. As you can see, it's difficult to do this on the tablet. It's much easier to do it when I have the formulas on a paper besides me and can do it. I think when you once have the strategy of dividing into these cases and then just start working on each of them, then watching the actual video of me doing this would be boring. So what I'll do now, when I think that we have made some mistake with the powers of 2, is just to do it on a sheet of paper. And I won't even show you the details or go through them. I'll just show you the results and then the final reconciliation, because when we get 4 different results, then we have to reconcile it with this formula. Hello again. Now it's the day before Christmas, and I've done what I said I would, to take a sheet of paper for each of the 4 cases. Here was the first one I did last evening, and there was a sign error, and today I don't understand how I could get that. Here we have I to lambda, and this gives I to lambda as well. So that gives minus 1 to lambda together, but lambda is even, so that gives unity. So we just delete this, and then everything is right. The next one, it's the same, and the extension. I did wrong first. Chose the wrong one first. But then it turned out right. And then we go to lambda odd, and here we wind up with the reciprocal of I times 1 plus I, which gives 1 minus I, which agrees with 216 again, because lambda is odd. And here it comes out the same way. So that was it. It's not quite routine, but it's not difficult. So, and it's actually part of studying the section, doing this, performing these calculations, or at least a couple of them. But here you have it all. And that's a Merry Christmas from me.